This time on Roadkill Garage, I'm gonna bore you to death with awesome electrical tech. He's gonna tunnel ram the F-Rod. We've got the comeback of the Gargantua wagon, Dulcige's Pontiac, and a little sneak peek of
the D300,
his favorite. The shop was built in 1975 and it just got insulated. Are we gonna have walls soon?
Oh yeah, I've got all the OSB in the back of the truck. I'm just gonna sheathe it, then I'll get it stuccoed and it'll be a whole new palace after that.
Nah, there's cars to build.
Freiburger, don't jinx me, bro.
Ah, the fraud. I'm still super excited, Dulcich.
Yeah, and check out the big block Chevy goodness.
It's gonna become greater as soon as you install
the tunnel ramp.
Exactamundo.
Are you all set up for me to do it?
Yes.
You've got everything?
Yeah, I think so.
All right.
This car is my biggest and best project right now. It's the 1931 Ford Model A called the F-Rod, or the Fraud. We've been building the thing over the past couple episodes, and it's got a big block Chevy in it, and my goal is to run 8s in the quarter mile, naturally aspirated. Now, on this episode, we're gonna get some visual pop to give you some more of like the look of what it's gonna become by installing a tunnel ram and dual dominators, and I'm gonna show you how to do really basic race car wiring. There's going to be lots of thought process on how the circuits are made, and I'll show you all that, plus some actual tips and tricks on how to physically do it. And at the end of the show, we've got a project car comeback that's going to be a big surprise. This is going to be like one of those YouTube box opening videos.
Oh yeah, but do you have the equipment to open this box?
Yeah, I bought this and I've never seen it before. It's a kind of tunnel ram I've never had, and it had to be a tall deck for that 572 tall deck engine.
Oh yeah.
Okay, there's the lid, and here is the tunnel ram.
Wow.
It's a profiler unit. What do you think?
Wow, that's pretty racy, actually.
Judge it, Dulcich.
I see about 2.5 degree of port taper, cross-sectional area of almost 4 square inches. Very racy.
Here's the lid. Of course, I got it for Dominators. You know, you can't have 4150s on a deal like this.
Do you have the gasket?
No, I don't think there is one.
No.
No, it's just...
RTV it. Yeah.
There's your answer. Do you say silicon or silicone?
Silicone.
Me too. How come it's the Silicon Valley, but it's silicone when you use RTV?
Point to ponder, Freiburger.
We're gonna start on the wiring segment. Every car that you're reasonably going to be dealing with is what they call a 12-volt DC circuit. So an automotive battery in a 12-volt system has 6 cells, and each one of them makes about 2.1 volts, which is how we get 12.6 volts at rest. I've got it marked with a positive side and a negative side. To start to draw a circuit, we pull a wire off the positive side of the battery, usually, and it will go up through a switch. Now, on an electrical diagram, you will often see a switch drawn like this, and it's pretty obvious. It's got 2 points and a lever, and it's either open like this or closed like that. This doesn't allow current to flow. This does. Next, we've got our load. I've got it as a light bulb. It is a resistance. So the electricity flowing through that resistance and going back to ground or back to the battery's negative post right here will light up that bulb. So that's how a circuit works. In cars, often you've got the battery grounded to the frame on one end, and then on the other end of the car, you will also have a light bulb grounded to the frame. So basically what you're using is the car's frame as a conductor just to return all power to the battery. The other thing that you've got in a typical automotive system is a fuse. If your amperage going through a wire, meaning your volume of power going through a wire, is too much, this fuse breaks and stops the flow of electricity. So that is the very, very basic stuff you need to know before we get going. Now let's look at the actual F-rod and take a deeper look into how I made it work. In order to start the complete rewire of the car, I did a ton of planning. No joke, I spent a week straight of like every free moment sitting around thinking, making lists, drawing out circuits. Let me tell you the few things that I do that are super helpful in making this happen. You can see this is my overhead view sketch of the entire car. And I think through every little electrical thing that I'm gonna have to deal with in the entire car, front to back. And I drew where they were sort of on the car, like for example, the battery in the trunk, and just made a good mental picture of everything that I was gonna have to deal with. Here is another interesting sort of diagram that helps me figure out where wires are going to go. If you look at this as the front of the car and this is the back, I've got segments here. This is the engine segment, this is the dash segment, this is the shifter panel segment, and down here is the trunk. I wanted to look at what wires are going what direction and through what area of the car so I can sort of figure how many wires are in each place. That does me a huge mental favor of picturing how to get all of this done. The other thing that I do once I've got sort of that big picture is I'll go through and identify every single circuit that I thought through, write it down. Then I will decide what gauge wire I'm going to use for that circuit, and then I identify what color every single circuit is going to be. There's nothing universal in car wiring that says what needs to be what color in the wire. So I chose that based on what wire I personally had in stock and what I could buy to save the most money, and identified all of the colors right there. Once I had all that figured out, I was able to go through and order all my relays and connectors and cross-throughs and battery covers and all sorts of stuff that I'll get to. The other thing is, once I actually get into wiring and finalize a circuit physically in the car, I will draw it out again to reflect exactly what I really did, because it might not be identical to what my plan was. I might have changed a color, I might have changed a wire attachment location, and I'll sketch that all out so I've got it in the future, so if there's a problem, I know how to go back to it and fix it. All right, let's get into what this particular debacle is, because it's going to be really helpful to a lot of people building race cars that are required to have an external battery on-off switch like that one. So I've got my battery located in the trunk here, and with most racing sanctioning bodies, and I know specifically with the National Hot Rod Association, anytime you got the battery in the back, you're required to have a master cutoff switch on the back of the vehicle that can be activated by safety and crew people, and it's got to shut the car down completely. It's right there. As a matter of fact, it's required to have that switch to be push off in most applications. Now let me show you how most people will wire a setup like this. You've got your battery, you ground it back here to the frame somewhere. Then you take a big, thick battery cable and you run it the full length of the car all the way up to the starter to crank the engine. That will go through the main disconnect switch, which is this thing I showed you right here. So that hot wire runs up to the starter, and usually at that lug, they'll pick up power for the fuse box, which powers all the accessories on the car, and usually it'll also go to the alternator, which is of course charging back to the battery. There's several problems with this common arrangement. First of all, when the main disconnect switch is on and the whole car's powered up, you've got one big fat battery cable that is hot, that's running the full length of the car. So it grounds out, or you get in an accident, it gets pinched, that's a dead ground, and your junk burns to the ground. The second problem is that the alternator, when it's hooked up this way, all of a sudden when you shut it off, it can have a voltage spike that'll damage the alternator. A much more common thing that does happen is the fuse box is powering the ignition system for the car, and the alternator is spinning at the moment that you hit this switch to shut everything off, and therefore it's creating enough power to continue to feed the ignition, and the car doesn't shut off at all, thereby not even meeting the NHRA requirement for why you've added the main disconnect switch. So this, while common, is junk. So the next thing that I'm gonna do is explain what all of this stuff is that solves all those problems. First off, let's talk about the remote starter relay. I know most of you have a starter relay on your car. Sometimes you might call it a starter solenoid. They're really two different things. A solenoid is an electrical winding that induces a magnetic field that causes something to move. A relay uses a solenoid to activate a remote switch. It's like a big switch that is triggered by a little switch. So on your typical relay, like the ones that you see right here, you've got two big power lugs. That is where the big amperage is carried. Then you've got two smaller lugs right here that can be triggered by very small wires to turn the relay on and off. That way, the relay can be in a remote location to connect high power that you switch on your dash with a little tiny switch and little tiny wires. You're gonna see this more later when we get into the dash wiring, but that is what a starter relay does. Now, in this case, what I'm doing with that relay is preventing that problem of the big hot battery cable running the full length of the car the whole time. By mounting the relay here in the trunk and triggering it with a separate circuit, I'm able to just run a little short battery cable back here. And so the big long cable that runs the full length of the car is not hot except when the starter is cranking. And that's what makes this important. I think I'm gonna go help Dulcich pull the engine out of the car because I gotta get him to installing the tunnel ram because tunnel ram is key to my very existence.
David's expecting me to put the tunnel ram on right now, but I really want to get the race power glide from Gearstar bolted right on and flex blade, torque converter, everything in place and swing that in the car. That 4-barrel intake manifold with the carb lift plate makes it way more manageable to handle out and back in. Once it's back in like that, you'll see the tunnel ram goodness come to life.
What's going on?
I'm gonna pull this out, gonna put your transmission on.
Oh, great.
Then I'm gonna put it back in, and then I'll put the tunnel ram on. You want the tunnel ram right now, don't you?
No.
The gratification of the tunnel ram. But man, you know, then I have to have the forward chain set up, and I'll scratch the cowl up, and...
Yeah, it totally makes sense.
Yeah.
Is it ready to pull?
Yeah.
That's pretty smart, though, Dulcich. I was gonna go right to the instant satisfaction.
I know.
Should this plate actually be bolted on?
Nah.
Okay, swing it out. There we go.
That was super convenient.
It was, but you see, the thing is, I don't think the starter is gonna clear that. And if we bolt the transmission on and then figure it out, it's gonna be a pain to fix it. So we need to get the starter and mock it up there before we put the transmission on, which means we have to wait for the starter to show up.
Mm-hmm. Is there any compensation for this thickness at the flex plate?
No.
No?
Though I wonder if there needs to be because of the torque converter engagement.
That's what I mean. I was just, the lugs are only engaging by 1/4 inch, and this is 3/16 plate.
Yep. That's a problem. So the issue with that is the flex plate's gonna bolt on here and the torque converter is gonna go on it. And if here's the torque converter and here's the transmission, we just move the transmission back. So the torque converter is not gonna engage into the front pump of the transmission as much as it should. I don't know if that's one of those things where it's just okay anyway, or if we actually have to run a spacer on the crank register. I just don't have the experience with a mid plate that thick. So I'm gonna have to do some research. If we do need a spacer, then we can't put the transmission on. You know, it snowballs all the time. So right now, once again, we're waiting for parts. So I'm gonna go show you some more wiring stuff. Let's talk making battery cables, which I have to do for the entire car. First of all, this battery cable is a standard 1 gauge, and you can see that it's got really, really coarse wire in it. It's not the greatest stuff. I like a much bigger cable, especially when I'm running the full length of the car. There can be a big voltage drop from front to back when the battery's in the trunk, and so I use this big stuff. And the reason this is so flexible is the inside of it is made up of a whole bunch of itty-bitty little wires all roped together in a big bunch so that it is nice and flexible and large and will carry a lot of power. So now let's talk about how I would go through and make a terminal on the end of this wire. First of all, to cut it, I will actually just roll the cable like so. Then I'm able to peel the insulation off and I'm down to bare wire. Then I can take the terminal and slip it right over that bare wire. The question is now, how am I actually gonna crimp that? First of all, the best thing ever is from Harbor Freight. It is a hydraulic wire crimper. Use if you want the cleanest crimp. There's another option, which is the smash tool. You slip it inside the tool, you smack it with a hammer, and it does get that lug solidly on the wire, but it's hideous. It makes like a big giant dent in that thing. So here's another option that's virtually free if you already have a vise. This is what I used to do as a teenager. Clamp that thing in there and ramrod the vise down. There you go. I just smashed that thing flat, but you can see it like puts weird dents in the thing. It's not the greatest way to do it. So what I'm gonna do now is strip the other end and get another terminal and show you my super secret cheap tip. This is what they call a nut cracker. Normally you would slip that over a stud with a nut on it, tighten this down, and boom, crack a nut open in order to get it off the stud. What I do is I go in and I round the shape of that tool right there on a bench grinder. You can disassemble this and get it out of there and turn it into a crimper. I just clamp it into the vise. Now I'm gonna take my terminal and slip it through there, tighten her down, 3/4 inch wrench, and voila. You see that I have a nice centered, even crimp that's on there perfectly solidly. And it's not perfect, but it's way better than the other methods that I've shown you, and it's the arguably cheapest way. Now let's have a look at heat shrink tubing. First of all, it is called 3-to-1 heat shrink, meaning it will shrink down to 1/3 of its normal size. The other thing that makes it great is that this has got the adhesive liner on there. It actually weatherproofs the seal and glues itself to the terminal, which on smaller wires can help actually keep them together, and on the larger stuff, it helps keep moisture out of them. And so there you go. Everything you need to know about making a nice battery cable, and now I have to go repeat it 6 times, making everything that I need for this car.
I'm waiting on parts for the engine and transmission, so while that's out, I've got a few little things to tidy up here. Number one, I've got to drill a hole for the bulkhead connector here that's going to take care of the fuel line because it's traveling through the frame rail. It's going to pop out through the bulkhead and then go on to the fuel pump and so forth. The other thing is the brake lines, they're just finger tight. Nothing there has been locked down, so I'm going to tighten all of those fittings where we've got the brake lines installed, and then I'll have a sense of accomplishment.
Now let's look at the next thing, which is solving that problem about when you shut off the switch, it might create a voltage spike that kills the alternator. I'm fixing that by simply running a wire directly from the alternator, boom, to the battery. That violates my rule of having a power wire running the full length of the car that's hot, but I can solve it with a 125 amp fuse right here. And that's this doohickey right there. It's called a mega fuse. Therefore, if that wire grounds out, that fuse blows, and I've minimized my fire risk, and I've solved the problem of shutting off the alternator and having it kill itself. I also use this Odyssey battery that has 2 power terminals. It's got the big cable that you would expect, and then it's also got a little 3/8 stud. And so I'm just gonna run the alternator right to that 3/8 stud. So that's very simple.
Freiberger just intrigued me with all that wiring stuff, and I'm just gonna put a starter in, so I've got the simple job here. Now, we were afraid that this plate wasn't gonna fit with the starter, and it does not work with the stock style starter, but I've got this aftermarket one, and as you will see right now, it bolts right in. Okay, that's a good fit. You can see it's actually flush. The mid plate fits nicely. A couple other things I have to do is install the freeze plugs where it had the rubber plugs before and wait for more parts so I can put the transmission on. What I'm using to seal the freeze plugs is gray silicone. This is kind of a rigid formula, maximum torque, so it holds in really nicely. You put the silicone in the hole. That way it collects right here on the inside corner where it does the most good. To drive it in, I just have a socket that fits the freeze plug pretty neatly. Now you gotta put it in dead straight. So there you go, freeze plug installation 101. Take it to heart, take it home, and think about it.
Next up, I'm gonna solve a couple more problems. One, I'm gonna get power up to the front of the car for all the other accessories, and I'm gonna do it so that I don't have a hot wire running up there when the main disconnect is off. This is also gonna solve the problem where you throw off that main disconnect and the car keeps running. Here's how I'm gonna do it. By powering the entire car through another relay. Now, it's really important to understand that I'm using continuous duty relays for this. These are genuine Cole Hersey brand 200 amp continuous duty relays. I hate to break it to you, these are 50 bucks each, but worth it. I'm gonna use the relay to turn on and off the main power to the entire car. So I've got my battery grounded back here to the frame. The power side is going to one lug on the relay. On the output side, I've got a 6-gauge wire running through another 125 amp fuse that's going up to the fuse box in the car. So the key is that this whole wire that powers the car is not hot unless the main disconnect switch is thrown. Now, to switch this relay on and off, I have a completely separate circuit that is not involved with the fuse box of the car. I'm picking up 12 volts here. I'm going through a 5 amp fuse. I'm going through this main disconnect switch. I also have a disconnect switch on the dash and another one on the firewall so that I can shut off all the power to the car at any time from any one of these switches. Therefore, I've got remote power on and off for the entire car by running main power through that continuous duty relay.
Finally, I got my parts so I can get things going on the flex plate install. Now, the consideration here was this mid plate. That adds thickness between the engine and transmission, and it compromises the engagement of the converter into the front pump of the transmission. So to compensate, you really want to add spacers at the back of the crank flange to make up for this thickness. Now, I've got 180 thousandths thickness here at the mid plate, and I'm only adding 140 thousandths shim. The reason is I need to retain enough of the register here at the back of the crankshaft so I have good engagement here inside the center of my flex plate. I'm gonna put the flex plate on, Loctite my bolts, torque it down to spec, and that part of this job will be finally done. Looks like we have some sort of problem here.
Why does it need to be hit with a hammer?
It's hanging up on the dowel.
Dulcich is hammering on my crank.
That won't go on.
They'll figure it out.
I was having trouble getting the flex plate to go over the dowel pin at the end of the crankshaft, so I'm gonna hit it with the countersink so it'll ease the installation. Okay, success. I got it to go on. It's zero clearance and it's a nice tight fit, so I'm gonna bolt it up, torque it to specs, and this job is done.
This is trick super drag racy stuff.
Yeah.
The trans that I chose for this thing is a Gearstar Power Glide. A Power Glide's actually an ancient Chevrolet design. Did you know they made cast iron cases and they were air cooled?
You're mansplaining me here. What are you doing, Freiburger?
It's true. It's a 2-speed automatic transmission, and they're super common in high-end drag racing applications for lightweight cars, and they have been for decades. The reason that I chose it is twofold. One, we're making a lot of power, and it's a lightweight car with a lot of gear, so I didn't think that I wanted a 3-speed automatic transmission. I actually wanted to tame down the launch with a first gear ratio that's higher than what we would have in like a Turbo 400.
It's not gonna be tame, dude.
I know, it's not gonna be tame.
What are you talking about?
This Gearstar unit is actually made with an aftermarket case. It's SFI approved, which means it's technically explosion proof. You don't need to have a trans blanket or an extra shield or anything like that to use this thing. And
What about the torque converter?
it is a Yank billet unit, and I hope it stalls at about 5,500.
Oh, yeah.
Yeah, it's gonna be super cool on the trans brake. Yeah, no, bam!
Yeah.
It's gonna be great. Let's install that garbage.
All right.
Okay, go up. Now, shove it in a little. There we go. There we go. Sweet. You got this, right? Because I have to go speak at length about wiring.
Yeah, go for it.
Well, I went as far as I can go in the trunk, so we're gonna move on to getting some wiring in the interior. So I was able to get the wires through the firewall safely with something called a cable gland. And it's from the computer industry, and it's really cool. You take it apart, and it's actually got a little rubber sleeve in there and a little grippy thing to hold the wire. This one perfectly fits a 6-gauge cable. It has a couple of nuts there that capture the firewall. They're usually plastic. This one is stainless steel. The next thing I'm gonna do is mount my fuse block and relay panel. And check this out. whoosh, swings right down for easy access while you're at the drag strip. So I can take this thing out and I'm gonna mount my fuse panel and my relay block on here and be able to wire it all up on the bench and then put it back in the car. So let me take this thing out and I will show you how that works. Now we're gonna learn all about the dash part of the wiring here. Instead of buying an entire kit, I got my own fuse block, and then I've got what's really cool, which is a relay block. And all you do with this thing is you put your main power in right here, and then you power your accessory out through here. And so things like my electric water pump, my electric fans, and my headlights are all gonna go through these relays. And they're gonna be triggered by these toggle switches, which are on the dash. So what I'm gonna have to do is figure out how to get that fuse block and this relay block on this panel in a way that I can route all of the wires so that the panel can still swing up and down and get the wires out to where they need to be. You can see that I have got one weather pack right here, which is a quick disconnect. So everything that I'm gonna wire is gonna have quick disconnects on it so that it can come out for service very easily. It's gonna be a lot of work, but I have thought it through. All that's left is to make it happen. It has been a long time, but this is gonna be a Roadkill Garage zip tie moment. Look at that doohickey right there. This is made by a company called Mag Daddy. You can also buy them from Mr. Gasket, and what it is a super strong magnet with a loop on it so that you can put on a zip tie. Watch this. Whoosh. Just like that. What makes it great is I don't have to drill any holes in my Model A, which is all steel, in order to hold down all my wires. This is working on the floor over here where you can see I've got this all tidy, and it's also gonna work up under the dash for hanging wires. It's the greatest. I am gonna show you exactly how strong this magnet is. They make two sizes, small and large. This one's large, and if I stick it on there, you hear that? Hardcore. Look how much I have to pull to get it off. That is one of the greatest things that I've found for use on this car. And that has been your Roadkill Garage zip tie moment. Now I've got all my wires draped in position. I promised you I was gonna show you how this all works, so here it goes. First of all, I'm gonna have a power wire coming from the trunk right here from that master relay in the back and powering up both my relay board and my fuse box. On the fuse box side, I'm only powering 4 circuits. I've calculated the amp draw on all of those, and a little tiny 20 gauge wire is gonna be no problem to power up these switches because I'm using this Leash Electronics relay board. And so you'll be able to flip the switch here, which will go through the tiny wire, which will trigger the relay, which will then send the main battery power out through a bigger wire out to the accessory. So the next thing that I gotta do is bench wire this switch panel that's gonna go near the seat with ignition, start, and trans brake wires, and then I'll be able to start mocking this actually into the car and figure out where wires are gonna drape and where to put all my quick disconnects. Boom. Okay, cool. I think that's as far as I'm gonna go here. I have to connect all these wires, and it's gonna be a lot. I'm gonna handle all of that at home later. So that's the end of the wiring part of the program. Yes. Here we go. I wish I thought this was the last time that this was going in the car.
That would be wishful thinking on your part.
I know. You need to come passenger.
I'm right between the jack stands now. Pretty well centered.
Keep coming. Okay, stop, down.
Going down?
This should be our easiest engine installation ever.
You think so?
Yeah, it looks like it's gonna swing right in, doesn't it?
Yeah.
Looking good. Ready?
Yeah.
Got it?
Yep.
Okay. It's in. Finally. Next step, tunnel ram. This engine is a GM 572 big block, and it was originally a crate motor. I rebuilt it a couple times, just freshened it up. It's got a different comp cam in it now. It's 269 at 50 solid roller cam, and it's got AFR 335cc heads on it. It's about 11 3/4 to 1. I've run it on pump gas before. It's gonna be a good training wheels engine for the hot rod.
Just what I was thinking. You read my mind.
It is literally my warm-up motor here so that I'm not too terrified for later on when we step up the power. Every time Steve estimates the tunnel ram power, it goes up. At first, I was like, I think it'll make 40. He goes, oh no, Freiberger, it's gonna make at least 50. Then like 3 or 4 days later, he's like, 75.
90 or 100.
Today, he's like 90 or 100.
Yeah.
Don't gack the paint.
I'm not gonna gack anything.
Whoa. Wow, that thing's mint.
Look how clean it is in there.
Will it fit between the rails on the heads? No. We're gonna have to do some grinding. So what's going on here is that there is a machined lip right here where they cut the intake surface, and often you'll find what we're seeing right now, which is the manifold will not slip between those two raised portions.
The good news is it's only like 20 thousandths of an inch.
Yeah, we can haircut it on both sides. I'm gonna count on you to draw a perfectly straight line and machine that as if it was in, you know, a Bridgeport.
I'm gonna be the human milling machine.
Yeah.
You know what, I'm just gonna hit that with the lap wheel on a grinder and chamfer that edge.
I figured you would.
It'll drop right on.
Okay, gotta line this up perfectly. Plop. Good. Are you ready for this? I'm so excited I could barf. This is gonna be the moment I've been waiting for.
Me too.
Yes! Now you get the picture of how fantastic this thing is gonna be. This is not your grandpa's Model A. So these are Holley 1050 CFM Dominator carburetors. And I went out of my way to get the gold ones so that it's retro style.
I approve, Freiberger.
Me too. So I'm gonna get these bolted on, and then the F-rod is gonna go back to Sam, who fabricated the roll cage and everything, and he is gonna make headers for it, which is gonna be the next level of greatness on the violence on this thing. I feel super happy. I'm on my way with the wiring, and that is radical. You know what else I'm excited about? The Gargantua wagon. My lost love has returned.
I know. I can't believe I never thought I'd see this thing again.
Oh man, I dig this thing so much. I'm glad it's back. What we're looking at here is our 1968 Chrysler Town and Country station wagon with 440 big block power. This thing was originally in my neighborhood sitting around forever, and I bought the thing dirt cheap, but it ended up in an episode of Roadkill Garage where we picked it up, we thrashed this thing around. I will say some of the best action ever on Roadkill Garage as I slid this thing around that big corner, absolutely blasting the thing. It was like my greatest stunt driving ever. But then we had a shootout with Lucky, and we went to the Camarillo Airport, which is now closed for automotive use, and we did sort of a shootout out there on the runway, and it was a lot of fun. And then we sold the thing, and so when the opportunity came, we bought it back. And I know you're questioning for how much. It was $4,500. We need to look at what's been done to it since the last time we saw it. It's different. All right, look at the color. That's not Chrysler blue.
That's like a 1980s show car guy paint job where they did the heartbeat with the pink and turquoise.
That's about that color.
Yeah.
You're right. Carburetor, is it? Hopefully it's a thermal quad.
Not a chance.
I'm gonna say it is an Edelbrock. Whoosh. Yep, Edelbrock.
Yeah, well, that's probably not a bad setup for a wagon.
What is all that wiring hanging over the fuel line right there? Oh, it's got the Mopar electronic ignition.
Yeah.
See the orange box on the firewall?
Yeah, it does. It's good installed.
Yeah, I would say this is not the way I would do it, but it's not horrible.
No, the electric choke's hooked up, so it's definitely not the way you would have done it.
I know. The coil's just a dangler. That's definitely the way I would have done that.
Yeah.
At least on Roadkill Garage. So this isn't horrifying. Let's check the dash, though. It looks like kind of a mess.
The dash.
Look at all this.
Yeah, the air conditioning thing's not even in place.
That vent is gone. This vent is gone. This wiring is all pulled out of the... I don't like this. Mm-hmm. Look at the vacuum octopus is out.
Oh, not the vacuum octopus.
That's bad. I'm kind of worried about just firing it up and driving with all those wires. You think it's okay?
It looks perfectly fine to me.
We need to get all this junk out of the back if we're gonna thrash this thing.
Yeah, let's do that. I'll be right behind you.
Oh man, why would you take these pillar things out? This stuff is never gonna get back on the car.
No, you can just put those in the garage next to all the parts to your 56 Chevy that are in boxes.
I know. This looks like we did it. This is all trash. That's all the air conditioning venting and stuff. That's never going back.
No way.
This air conditioning stuff is trash.
Oh, no, it's not. That's super rare stuff. Are you kidding me?
I'm throwing it all away when you're not looking.
This is like super rare air conditioning stuff for a 68 Chrysler.
Oh, look, why would you take the fender-mounted turn signals off? I don't get it.
I don't know.
You know what the problem here is? If I had just bought this car, this would be like discovery of like, ooh, here's the thing. Ooh, I can put this back on. But instead, since I know the car, I'm going through this and going, why would you do this?
Freiberger, the guy must have been a show fan.
Oh, apparently.
Yes. Shift link, battery cables.
Recycle, do not throw away. We're gonna go drive the thing around and see how the Gargantuagon has survived throughout its period of our non-ownership. Oh, wow.
Wow,
The
power
brakes weren't good. The parking
Why
brakes
is it dragging?
definitely dragging.
Yeah. Are you sure it's the parking brake, or maybe it's just the service brakes were rebuilt and never adjusted properly?
That's possible. This is not gonna work. It's gonna smoke the brake drums like fast.
Yeah.
Wow. My mood is not improving.
I wonder what happens when you hit the brakes at high speed and the rears lock up. You think that's gonna happen? Steps will get up and go.
Wow! This thing's almost undrivable because of the brakes.
Really?
Yeah.
Oh.
Ah, dude. The front brakes are totally locked up and smoking. This thing is FUBAR.
I know. What are we gonna do, Freiberger? How are you gonna get that wagon experience you've been waiting for all day? Tell me, Freiberger. How about if I tell you, man?
What?
How about if I just gift you this, bro? I take you on a cruise in my Bonneville station wagon.
Oh. I actually forgot we even had the Bonneville station wagon.
No. Yeah.
Oh man, we drove that thing all the way to the Bonneville Salt Flats. That guy's driving way too fast. That could be us.
Yes, let's go. Let's do it.
So Pontiac 400 headers, 214 cam, what carburetor?
625 AFB. But the thing is, I've got them GTO heads on this thing.
What is a GTO head?
Well, I mean, if I was a Pontiac guy, I could be more specific, but they have high compression heads and low compression heads.
Yeah.
They have big valve heads and small valve heads.
And so this is high compression, big valve?
Yeah.
Oh, rock and roll.
This is what you've got.
I recall this thing having a 256 rear end gear.
It's pretty high, whatever it is.
We're going 80 right now in second gear.
Yeah. Freiberger, I feel pretty good about this week. I mean, we got a big chunk of the F-rod done.
Yeah, I'm super happy on that.
We found all the problems that we've got to fix on the Gargantuagon.
That depressed me.
I broke out my wagon to cheer you up.
That cheered me up.
I know, look at that smile on your face.
Yep.
And we got to see the D300 full of wood fixing up my shop.
Oh yeah, maybe we should fix up the actual Roadkill Garage on the next episode of Roadkill Garage.
I would be all for that, although...
Nah, that's even more boring than electrical wiring.
No.
Man, we got a lot of project cars going on this season. Stay tuned for even more next time on Roadkill Garage. The audience will be disappointed if the Gargantuagon is just left in its currently pathetic state.
Yeah, I know, but I don't want the challenge. I don't want the competition.
Dulcich, your garbage won't even do a burnout. Ooh, you have a broken motor mount.
That's what that is.
Oh, yeah.
That's a broken motor mount.
Total broken motor mount. You can't even do a burnout.
Well, yeah, 'cause I've got a broken motor mount, bro. How am I going to do a burnout with a broken motor mount?
Do it in reverse. It'll flex the engine the other way.
break the other one, then I will have no motor mount.
Do you really think it would flex the engine the other way? The engine still makes torque that way.
Oh, it does, you're right.